So we're now going to do an example of integration with respect to x. And our example is to compute the integral over c of x plus y dx, where c is the portion of the parabola y equals x squared from the point -2, 4 to the point 1, 1. So let's just draw that in the corner over here. Okay, so to compute this, we need to choose a parameterization. So we can use x as the parameter in this case because the curve is the graph of a function, y of x. So we could take x to equal t, y to equal t squared, and then t goes from -2 to 1. Okay, so remember that this integral is well defined. It depends only on the orientation of the curve. And the use of the word from and to here indicates that I should start at -2, 4 and end at 1, 1. So the arrow is going like this. So as long as the initial point of my parameterization is -2, 4, and the final point is 1, 1, I'll get the correct answer. Okay, so we can use this parameterization. And then the integral over c of x plus y dx is the integral from -2 to 1 of x of t plus y of t times x prime of t dt. So x of t is just t, and y of t is t squared. And x prime of t, well, that's 1 because x equals t. So that's a 1 here, which I guess I didn't really need to write there. And we put a dt. So when we integrate this, we get t squared over 2 plus t cubed over 3, evaluated at t equals 1, then t equals -2. So at t equals 1, I get a half plus a third. And at t equals -2, I get 2 minus 8/3. So this is 5/6 plus 2/3, which is 9/6 or 3/2. All right. Now, this is not supposed to depend on the parameterization. So let's try another parameterization and see if we get the same thing. So how about, let's see. How about x equals t cubed? You know, since y is supposed to be x squared, we better take y equals t to the 6th. And what's the range of t? Well, we want to start at x equals -2, which means that t is the cube root of 2. And then I want to go up to where x equals 1, which is where t equals 1. Okay, so what do we do if we do it that way? Well, then I get the integral from, sorry, this is the cube root of -2, excuse me. Okay, so I start, or minus the cube root of 2. So I start at minus the cube root of 2, then I go up to 1. And now I have x of t, which is t cubed, plus y of t, which is t to the 6th. I have to multiply by x prime of t. Now x prime of t is 3t squared. And I put in a dt. Okay. So this is the integral for minus the cube root of 2 to 1 of 3t to the 5th plus 3t to the 8th dt. So this is t to the 6th over 2 plus, that's an equal sign, not a plus sign. So t to the 6th over 2 plus t to the 9th over 3, evaluated at t equals 1, then t equals minus the cube root of 2. So now if you compare this expression to this expression, you'll see that they're exactly the same. It's just that t over here gets replaced by t cubed over there. But otherwise, the calculation is going to come out the same way. So we're still going to get 3/2, just as before. All right, now let's try third parameterization. So let's put it over here. So parameterization number 3. So now we're going to go backwards. So we're going to say x equals minus t, and y is the square of that, which is still t squared. So t is going to start at minus 1, that's where x equals plus 1, and it's going to go up to 2, which is where t is minus 2. So using this parameterization, I get the integral from minus 1 to 2 of x of t plus y of t times x prime of t dt, which is the integral from minus 1 to 2. So x of t is now minus t, and y of t is t squared, and x prime of t is minus 1, and then I have dt. So what is this? So here I have minus t times minus 1 is plus t, so I get t squared over 2. And here I have minus t squared, so that's going to give me minus t cubed over 3. And we're going to evaluate this at t equals 2 and t equals minus 1. So at t equals 2, I get 2 minus 8/3, and at minus 1, I get a half. Minus 1 over 3 is plus 1/3. And if you look at this, this is minus what we got over here, so the final answer I get is minus 3/2. So you might think, well, we screwed up somewhere because we were supposed to get plus 3/2. But remember, switching the orientation switches the sign. So in parameterization number 3, I'm starting at the point 1, 1 and ending at the point minus 2, 4. So that parameterization has the arrows going the other way. So we're supposed to get minus what we got before. Okay, so that's an example of how to compute integrals with respect to x and how they depend or not on the parameterization.